class we can start it properly. That is first. Have I started something? I don't remember. Unit. So let me just tell you the portion of Unit 3 first. Unit 3, the chapter name is application. And application किसका रहेगा? Derivative का और it is just applications. So the syllabus is first thing is second order Taylor's formula. Taylor's formula for scalar field. See अभी तक हम लोगों ने जो भी किया सब स्केलर फील्ड के लिए किया है. We use the differentiation, directional derivative, total derivative, everything was for scalar field. The second topic is differentiability of vector field. Finally, of vector field. You'll see the relation. Third is mean value inequality for vector field. Next thing is to find maxima and minima. Maxima and minima. See, maxima and minima we know for the function of one variable, correct? If your function is for one variable, you know how to find maxima and minima. But what if your function is of two variable, three variable, then how to find maxima and minima? We'll be doing. And one more saddle point. And second derivative and one more most important, that is method of Lagrange multiplier. Method of Lagrange's multiplier. What is this method actually? This also gives if you are having some function and given some constraint, then if you want to find maximum, then also you can do that. This is if you are having single function, you want to find maximum minima, then there is some test you can do, you will get maximum minima, and this is most important. Method of Lagrange multiplier. This is very useful in many cases. In physics also this has many applications, you will see. Okay, so shall I start or maybe from next lecture? Do you want? Yes. Hello. Yeah, I'll just quickly define it, then maybe we'll start. See, why Taylor's theorem is useful. First of all, let us know. Taylor's theorem is useful for approximating a function near a given point. Near a given point by means of polynomial. Okay. So what was recall your Taylor theorem of first one variable, that is f of e plus h, can be written as f of e plus h into f dash of e plus h square into f double dash of e upon 2 factorial. If you remember your SyBsc, then h cube into f third derivative of e upon 3 factorial and so on. Correct. Now we will extend the same definition for two variable. Okay, I'll just state the theorem. Taylor's formula for a function of two variable. Okay, so let S be a non-empty open subset of R2. S be non-empty open subset of R2. Let E1 E2 and E1 plus H comma E2 plus K be any 2 points in S such that the line segment joining these 2 points lie entirely in S. Lie entirely in S. Okay. Suppose F from S to R possesses continuous partial derivative derivative of order n plus 1 then f of e1 plus h comma e2 plus k that can be approximated by f of e1 e2 plus h into dou by dou x plus k times dou by dou y f of e1 e2. Next, plus h dou by dou x plus k dou by dou y the whole square upon 2 factorial f of e1 e2 of f1 and so on. It will be h dou by dou x plus k dou by dou y the whole raised to n upon n factorial f of e1 e2. Okay, and last term that is remainder term जिसको बोलते हैं that is h into dou by dou x plus k times dou by dou y raised to n plus 1 upon n plus 1 factorial, and that is f of e1 plus theta h comma e2 plus theta k, correct, where theta is between 0 to 1. So this is your Taylor expansion. So do you see the relation, मतलब वैसा ही है जो पहले था तुम्हारा. Here this is at the place of derivative you are having this thing h dou x plus k dou y, because we'll be using chain rule. This is actually more often a chain rule. So how we are going to prove it? We are going to change this double variable function to a single variable. We are going to relate this function with one variable. That means we'll be defining a function so that this double variable will change into one variable, and then we will try to use the Taylor expansion of one variable, and that's it. Yeah, should I prove it? It will not take much time. Let us do the proof then. So define a new function. Define a one variable function. Say g from 0 1 to r by g of t equal to f of e1 plus th comma e2 plus tk. So I am defining a new function g of t, that is f of e1 plus th and f of e2 plus tk. Now you see that since f is n plus 1 times differentiable, so g will be also n plus 1 times differentiable, correct? since f is n plus 1 times differentiable implies g is also n plus 1 times differentiable. So can I use Taylor expansion of one variable by Taylor theorem for one variable जो FYBSC में किया था, that is same 2. I think last में हम लोग ने किया था. So what is that? Around 0 suppose I am putting. So g of t will be g of 0 plus g dash of 0 plus g double dash of 0 into t into, and it will be t square by 2 factorial and so on. It will be g nth derivative of 0, that is t raised to n upon n factorial into g nth derivative of 0 plus remainder term. What is that remainder term? T raised to n plus 1 upon n plus 1 factorial g n plus 1 of theta, that is 0 plus theta or a plus theta, whatever you say, where theta is between 0 to 1. So now you just have to relate what is g dash of 0, what is g double dash of 0. That's it. So how will you do that? G of t is f of e1 plus th comma e2 plus tk, करेक्ट. सो लेट ये जो टर्म है उसको हम लोग अल्फा ऑफ टी बोलते हैं. लेट अल्फा ऑफ टी इक्वल टू दिस e1 plus th comma e2 plus tk. Now I can use my chain rule. That is, what is my g of t now? G of t is f of alpha t, correct? By applying chain rule, what will you get? Chain rule, that is g dash of t will be, yes, it will be delta of f of alpha t into alpha dash t. ये होता है ना chain rule. So what is delta of f of alpha t? So f of alpha t delta निकाला तो ये क्या आएगा? It will be dou f by dou x, and alpha t it will be with respect to किया तो it will be h, correct? That means what? This will be just this dou f by dou x of alpha t comma dou f by dou y of alpha t, right? मतलब इधर भी चेन रूल हो जाएगा, मल्टीप्लाई बाय डेरिवेटिव h comma k. So what is that? You can write the whole thing in this form. Function को बाहर निकालना है f of alpha t, then you can write dou by dou x comma dou by dou y f of alpha t, and h and k को शायद इधर भी, हाँ डॉट प्रोडक्ट ले लेते हैं. Let us take dot product. So I can write this as h dou by dou x plus k times dou by dou y, and of which point? Of f of alpha t. That's it, correct? So I'm having my g dash of 0. G dash of 0 is what? This one, h dou by dou x plus k dou by dou y f of alpha t. Let us go back and check first term मिल गया क्या अपना? You see, प्रूफ क्या करना था? f of e1 e2 plus h times this. I am getting my first derivative, वही मिल रहा है. G dash of 0. Similarly, if you want to find double derivative तो कैसे निकालोगे? You have to find g double dash of t. हाँ, at t equal to 0 it will be, sorry, g dash, ये तो g dash of t आया ना. At t equal to, it will be alpha of 0. So what is alpha of 0? It is a1 a2. It will be e1 a2. So ये हो गया. What is this? g dash of t. So if you want to find double derivative, differentiate g dash of t. What is your g dash of t? This numerator part, that is h dou by dou x plus k dou by dou y, multiply with this guy. पहले तो थोड़ा सॉल्व करना पड़ेगा इसको. This is f of alpha t. So you have to differentiate this again. Differentiate g dash of t once we get using chain rule again. So if you apply chain rule, so now you see something. You want to find g dash of t, correct? And g is in terms of some function alpha of t, and that is actually some function that f that is in x and y. So g dash of t, g double dash of t, it will be what? Dou by dou x of whatever the function is, multiply by dou x by dou t, multiply by dou x by dou t. That is the chain rule, na? Plus dou by dou y, whatever your function, multiply by dou y by dou t. Correct? Now dou by dou x of whatever that function is, that is h dou by f को साथ में लिख लेते हैं suppose. So it will be h dou f by dou x plus k dou f by dou y. And here also h dou f by dou x plus k dou f by dou y. Just solve this thing. If you take multiply this part, find, it will be derivative of each part and multiply dou x by dou t. So what will be dou x by dou t? What is my x? X equal to e1 plus t. So it will be just h. So in next case, this will be h and this will be k. So if you multiply, you will be having h square dou square by dou x t. This will be this. H square dou square f by dou x2 plus 2hk dou 2f by dou x dou y plus k square dou square f by dou y square. This is what you will get. Just do that. This is double derivative and this will give in y. यहाँ पे x and y का आएगा एक और यहाँ पे भी x and y का आएगा. It will be 2 times. So this can be written as h dou f by dou x plus k dou f by dou y the whole square. Correct? And one thing you need to make sure, that is dou square of f by dou x dou y. This is same as dou square f by dou y dou x. Why? Because it has continuous partial derivative. Function has continuous partial derivative. So what will be my g double dash of t now? It will be same thing, h dou by dou x plus k dou by dou y the whole square of function f of alpha t. Alpha t का वैल्यू भी पुट कर सकते हो. And what is g double dash of 0? It will be h dou by dou x plus k times dou by dou y the whole square f of e1 e2. Do you see the next term? यही चाहिए था. Correct? So now you can write similarly, we can get all the term. Do निकाला, that's it. You can write similarly. Similarly, g triple dash at 0, it will be h dou by dou x plus k times dou by dou y whole cube f of e1 e2. And g nth derivative at 0, it will be h dou by dou x plus k dou by dou y raised to n f e1 e2. Correct? And n plus 1 भी मिलेगा similarly. And what you have to do next, you have to substitute in the equation. Substitute it where? Here, g of t. So what is g of t? It will be f of, and t का value you need to substitute t equal to 1 because हम लोग को f of e plus h चाहिए यहाँ पे. Do you see? यहाँ पे E1 plus H और E2 plus K चाहिए अपने को. We want E1 plus H and E2 plus K ना. So put T equal to N and substitute everything. Put all the derivatives, that is G, put all above terms and T equal to 1 in star, you can say. And this is my original star. इसको star बोल देता हूँ. So if you substitute, you will get your result. That is, this will be G of 1, that is equal to, what is G of 1? That is f of E1 plus H, comma E2 plus K, and that will be f of E1 E2 plus H into dou by dou x plus K times dou by dou y, multiply with f of E1 E2 and plus 1 upon 2 factorial H dou by dou x plus K times dou by dou y, the whole square f of E1 E2 and so on. Nth term will be 1 upon n factorial H dou by dou x plus K dou by dou y raised to n into f of E1 E2 and plus that remainder term t raised to n plus 1. t नहीं है ना अपने पास, we have that will be upon n plus 1. It will be 1 upon n plus 1 factorial h into dou by dou x plus k into dou by dou y raised to n plus 1 into f of E1 plus theta h, comma E2 plus theta k. Correct? Yes. Hence proved, which completes the proof. You see that हम लोग ने क्या किया, जो 2 वेरिएबल का था उसको 1 वेरिएबल में लिखा and just using chain rule you can prove it, the derivative in 2 वेरिएबल. Similarly you can try for 3 वेरिएबल. इसमें क्या रहेगा, there will be जहाँ पे h, जो ये टर्म है, this term h and k है ना, there will be one more variable, वो और आ जाएगा h, k and l. You can take dou f by dou z. That will be the changes, everything will be same as it is. This is called Lagrange form of remainder. जो remainder part है, this part is called Lagrange form of remainder. Okay. Next lecture we will see the remark, and there are some approximation up to tooth derivative if you take, and if you take only 2 term, if you take only 3 term, linear part चाहिए तो if you take only first term. We'll see it in the next lecture. There are some problems based on this, then this will end. Then we'll start with differentiability of vector field. Just ये include इसीलिए किया गया to see the application of chain rule in this. You see that which use the chain rule. You try to prove everything once again by yourself, then you will realize whether you are able to do or not. Okay, yeah. Thank you so much.